you in or?
No, like it shows up like. Let me see. Right. So like it says like click to join call. Earlier it said that, but now like it doesn't let me. So I was like, and this button right here, I'm like, I should probably press that if I want to join the call.
That's weird.
Weird. Okay. So.
All right. So we're doing the first one from last week. So it's the week 5, lesson 3 and 4.
Sounds good.
So.
Put in my charger.
But yeah, I think if we just do the extension problems, we should be good.
Okay.
Do we need to? Yeah, we don't. And Natalie, let her know.
I'll email her right now.
Okay.
See what she says to me, if she even says anything. You guys start discussing.
Okay.
Let's do these fast. I have a lot of homework to get done tonight before I go to sleep. So.
Cool. I'm down.
So isn't it this the same as saying like 3 times log x minus 1? And the same in the other side or not?
I'm opening it up. Okay.
Okay.
So it's the one that says 3 to the x minus 1 power.
Yeah.
Wait, so I mean, if it's the same base, technically it's x minus 1 equals 2x plus 7, right?
I think that you might be right.
I don't disagree with that.
But I think that it would be like log of that. And then it's like multiply. Look at the example 4 in the book. Is the equation involving 2 exponential expressions. Look at, I can show you guys. This one, I don't know if you guys can see it.
Mm-hmm.
So this 6 to the x, they put it in log, and then they took the x out, and isn't it something like that that we should do maybe? I don't know if it makes sense.
Yeah, but this isn't a log, it's an exponential function. I don't know at this point that we...
But this is an exponential function too. Both of them. They are the same. The difference is that they have different base. Okay, let me see if I can find another one. Okay, let's try to solve it the way that Bloody said.
Alright,
So you,
it's like weird right now. The answer is negative y. So I'm just trying to figure out how you get negative y. Because I did this the way I did, and I got x equals -8. But
I don't think that answer is right because that's what I got too. Was negative x is equal to -8.
yeah,
I think that is really wrong. The answer, kid. Like always.
Because yeah. So Vladi, did you do so? Once you have x minus 1, 2x plus 7, you add 1 to both sides to isolate the x. Then you subtract 2x and get negative x equals 8, and then divide by -1,
yeah.
and you get
X equal -8.
yeah. You just flop the negative.
That's what
If
I
they
get.
have this.
Are you showing us, dude? Your camera's autofocus is horrible.
It doesn't
All
look so it's weird.
I feel like I'm like 80 years old looking at like a piece of paper.
Andrew, make fun of Andrew. No, I'm just kidding.
Yeah,
You can
no,
make fun.
that's good. Then
Okay.
okay, so okay, we're good with that one. If no, we should ask like what is that they really want, because not even the answer before they used to lead us like where we needed to go, but now we just can't. Okay, discuss the method used for solving and why it works.
For that one?
Yeah, well, that's what it says.
Didn't we
For
just
all
do
of
that?
them.
It just works. I'm just kidding. It's I guess the equation is
Well, the rule is that if the base is the same, then you just eliminate the base and then solve.
yeah, exactly.
And that is why it works.
All right, the next one.
Okay.
So these ones are bases are different, but we can multiply to get the same base. We can make the left side the base 16. So, yeah.
Like 2 to the 4.
Are you talking about the 2x minus
the
2
four.
make it 16, or talking about converting the 16 to a base of 2?
I guess it'd be
Yeah.
easy. 16 to the base of 2.
Yeah, that would be easier.
Isn't it?
So what, you get 2 to the 4?
Yeah.
Put the x right there. So 2 to the 4x.
Yeah, it's like parentheses 2 to 4 and then x. But I think that the rule is
Yeah.
if it's a raised to b with c outside the exponents, and it's just a raised to bc, right?
It will be 4x because they multiply.
For 2 raised to 4x.
Yes. Because it will be 2 to the 4 to the x, and they multiply, so it will be 4x.
Mm. And then you'd have 2. That's
And then would be
2 raised to x minus 2 equals 2 to 4x. So then you just get rid of the 2, so you have x minus 2 equals 4x.
Yeah.
And then
Well, the answer I got matched the answer key.
then you would add 2 to both sides, which would basically make it x equals 4x plus 2, and then subtract 4x from both sides, So then your negative 3x equals 2. And then, yeah, divide by 3. So what, negative 2/3?
Yeah, that's what I got. I was just trying to write it bigger, but it's super blurry.
Cool.
Yep.
And that works because it does.
Sweet. Makes mathematically sense. So.
Absolutely.
All right, next one. X minus 2. Natural 3. So natural log is also like the same base, technically, right?
Right.
So it would just be like x minus 2 equals 3x plus 11.
Yeah.
Brain farts going on.
Yeah, so you would get rid of the natural log. And then
You know, 2 people that put their video. Awesome. Oh my gosh, how do we fuck?
What?
So is it x equals negative 13 over 2?
Mm-hmm. Have you guys checked any of these to make sure that they work?
No.
Okay, I'm gonna check the first two. Why don't you guys check this one?
So I guess you can't have a negative inside a natural log. Like this wouldn't have a solution.
First one's good.
So what do you get in the third one?
So if it's not working, then there's no solution, right?
Yeah.
Okay. So what's the problem with the number 3, or we're done with number 3?
Since you can't have a negative inside of a natural log, it's automatically like error on the calculator.
Okay, and you got negative 13 over 2.
Well, yeah, it was negative 13 over 2 minus 2, right? So that's negative 17 over 2. So either way, it was not going to work. I only did the left side, and it already didn't work, so that's why. That makes sense. So I just subbed in x. So that you're right. It was x equals negative 13 over 2, but I just put it into that left side of the problem, and I calculated that on the calculator to make sure it would actually go through or not, and it didn't go through, so it's not a solution.
Mm-hmm.
Number 1 and number 2
Where do
are
you
good.
get that negative 2 from?
So that's from the original problem. I didn't x minus 13 over 2 for x, and then that's minus 2.
Then you have just x minus 2 equal to 3x plus 11, right?
Yeah, on the other side, but I didn't have to like insert it in because it's already a negative on the left side. It was automatically not a solution.
Yeah, it's just that I don't know how you got the 17 because it's just 13. Because you move, then you just have the 11 to the other side, and then you have like 13, negative 13 equal to x.
That's what he has.
Hmm?
He doesn't have negative 17. He has negative 13.
No, the answer was like negative 17 over 2. Because
No.
the negative 2 I just made into... No, I mean, that's not the answer, but that's just the left side converted with x inside.
Oh, when you put it in?
Yeah, so I changed the negative 2 into a negative 4 over 2 because that's the like term, so this will just actually subtract fine.
Okay, so there is no solution.
Sorry. Yeah.
It's all good. That makes life easier on us.
Let's go number 4 then. Oh, this is the one. Oh, no, never mind.
You got really excited there for a second. What were you going to say?
Yeah, that it was similar to the quiz, and I didn't know how to do it. And then, like, the answer were in the homework for this week.
Oh, really?
Yeah, because they taught us how to do it in this week homework. Well, here we have the same thing. They have the same base. So isn't it that the same? Right? Right.
What? Same base?
Mm-hmm. For the log. 2x plus 1 equal x squared plus 1.
Yeah. Mm-hmm.
Yeah. You set them to equal each other. I got x equals 2.
How do you get x equal 2? You get set x equal x squared over 2.
Mm-hmm.
And because of that, it's just x equal 2.
Yeah, so you get, if you take out the ones, like minus 1 on both sides, then you get 2x equals x squared. So I just divided 2x by x to isolate the other side. So you would get x, yeah, x equals 2. That's what would be left out. So you divide both sides by x.
Gotcha.
Theoretically, though, on this equation, shouldn't you put it into the quadratic formula?
You could, yeah.
But if you put it in the quadratic formula, that means that you're going to get two answers.
A 0 and a 2. So we're good. Should we put it in the quadratic formula?
I'll do it right now just to make sure.
Well, the option in the answer key is 0 and 2. 0,
Oh, is that?
2. Yeah, x. It's just given in a coordinate x equals 0, 2.
Well, give me 1 second and I'll do it, and I'll let you guys know.
So you are setting it just to like quadratic equation and then that quadratic formula.
Yeah, so it's A is -1, B is 2, and then C is 0.
Mm-hmm. Let's see. Yeah. Oh, no, that makes sense. If you have 0.
Yep. So it's 0 and 2.
Sweet. Sweet. Sweet.
All right, next set of things. Graphing.
Woo!
Yeah.
Easy peasy. We got this.
Oh, I just totally wrote this stuff down today.
Mm-hmm. Yeah, I have some examples right here too. I went to a tutor last week twice.
Did you?
Yes.
Nice.
The hardest part was graphing, so first of all, we have K right there. I went to a tutor and I already forgot everything.
So K it moves up 1.
Right. So if we have the graph, we know that it moves up. If we have -3, we know that it's inverted. And because it is 4 to the x minus 2, we need to know what kind of graph we're graphing. If it is 4 to the x, it's just like a line, a curve, right? Sorry, I'm looking for all my notes from tutoring.
Good, man.
Okay. Here we go. So it says so let's identify the asymptotes. So to identify the vertical asymptote, we need to set the denominator to 0, and we don't have a denominator. So.
Well, so the equation is negative, so it's going to be reflected over the x-axis.
Right.
Which means it's going to go down.
Right.
If you're moving it up 1, and let's see.
But what kind of graphs do we have here? Do we need to change it to vertex form maybe? Or something? It is in vertex form. Yes. So we have the vertex. Hey, where is that thing?
Yeah, it's 2, 2, 1.
Negative. Oh, is 2, 1. That is the vertex.
Yeah. So your asymptote is going to be y equals 1. Asymptote.
Asymptote. Yeah, I didn't. You say I don't know what you said. So okay. So we have that in vertex form. Cool. Actually, man, this is a lot of math. This is too much math. But what kind of graph are we doing? Isn't it this just like a line? Like it should go, I mean, if it should go up, but because this is inverted, it will go down.
Bears beats Battlestar Galactica.
No, it doesn't.
What are you doing? Okay, Dwight. Goodness sakes.
Okay.
Okay. So theoretically, shouldn't your graph be like if it were a positive graph, it would go up. It would start low and go up like that.
Right.
So if it's reflected over the y or over the x-axis, it's going to go straight and then down.
Mm-hmm. So what is our asymptote? Our vertical asymptote is 1. It can.
No, I think that's a horizontal asymptote. I don't think you have a vertical asymptote.
The horizontal one is
Y equals 1.
y equal 1.
Mm-hmm.
I found one.
And that is our vertex, isn't it?
The vertex is 2, 1. What did you find, Vladi? Did you find that?
I found 1 point because I put 0 for x to make 1 point.
If you do that, you are looking for your x
I'm gonna
values,
y
values.
Your y-intercept?
Yeah.
Uh-huh.
Yeah, so that's the y-intercept.
0, what is it? 0, 13 over 16?
0, 13.
Okay.
Yeah.
0, 13. But wait, 0, 13?
It's the x value is 0, the y value is 13 over 16.
Oh, 13 over 60.
Okay.
That changes everything because it can go up whatever was asymptote.
Does that mean it goes up? Does that mean it goes up in between 0 and 2?
What's reflected? So
13 over 6 over what? 60?
Mm-hmm.
Yeah, 13 over 16.
So it's 0.21. So it's okay, that makes sense. And it is reflected. But so, and we have our vertex.
I found another point. It's 1 and then comma negative 1/3 is another point.
Did you say 1 comma negative 1/3?
Yeah.
Zero 0.3. So in x equal 1, it is negative 0.3. Still looks like a circle. Here we go. Yes.
another points.
Can,
2, comma 2.
can we use a calculator to like graph these things?
Sure. I'll put it in. I actually don't remember how to put it. All right, there you go. Now I do.
We got 20 minutes left for these ones. Then I'm cutting this off.
To start the other one?
Mm-hmm. We're catching up, boys. How was your free Thursday night? You didn't have to talk to me.
It was beautiful.
Oh, was it? This was beautiful. Nice.
Huh. How do you put points again on your calculator? Forgot.
I think it depends on the calculator.
I got one of these.
One of those Dwight 5000s.
Yep.
Is it an 83 or 84?
Oh, look at what I had. This is not sharing, isn't it? There it is. That's what we want. And that's what we get. So we're good. .8 on 1.2. The y coordinate is 0.813. And
Yeah, that's 13 over 16.
Right. And then the x is 1.208. And we know that the asymptote is
1.
1. So that's why I start from the left part of 1. It goes through that and then 1. And that's good.
Cool.
Okay, let's go move to the next one.
Next one.
Okay. We know that is inverted again. Okay.
Would we need to change this to vertex form? I guess it kind of is in vertex form, but
Here it says that y equal a to the x and y equal logarithm of base a x are inverse functions. They are a reflection of the line of y equal x. So we have the line y equal x. We know that y, the function will go down 3, right? And it will go to the left 1. to know that that is our the vertex. -2. Isn't it that?
Got it. Okay.
What do you get?
I was looking at this and I'm like, I know I wrote down the transformations for logs somewhere today. I went through this. So it moves to the left one.
Right. And down
And then
3. Right?
Yep, should.
And then it is inverted, so it's going down.
Mm-hmm.
And
it should be
shrinks. It stretch. And if it is a stretch, it make it bigger, right?
Mm-hmm.
So it is, well, but what kind of function is this? It's just an exponential function.
I was going to say, wouldn't it be an exponential function regardless, just because we're doing
A log?
Yeah.
Yeah, I think so. It will just go down.
So theoretically,
So that is what
excuse me.
let's see what we get when it comes to the actual graph.
So because it's like the 1/2, that's a decay function.
Mm-hmm.
Like that's the, hold on, I have it here somewhere. Okay, maybe I did. Yeah, I think it's a decay. So like normally a decay function would be like down and over. You know what I'm saying? Where'd Vladi go?
No idea. Okay, so it
Just
will
talking,
be an
talking to the
exponential
ladies.
Function, but it's inverted and is stretched by 2, and the vertex is -1, -3. Right? Or not?
Yeah. Did you throw it into a graph?
I was trying to, but with log, I couldn't. Oh, let me try it again. I have another idea on how to do it.
Here, I have it right here. There's your graph, Gabriel.
Okay. Yeah, it doesn't like it this. Okay. How do you graph that? But wait, can I see it again?
Yeah, hold on.
So the vertical asymptote is negative what? And what are those y coordinates in?
So it's 0 and -3 is the y-intercept, and the x-intercept is 2 square root of 2 minus 1.
But it can't be -3 if it is moved to the left 1. If it is -3, -1, the y-intercept it can't be -3.
Hmm.
Oh, okay. Look at what I have. It's completely different, but I don't know. Do you see that? And that is the function. I think that's what it.
No, that's not the function, though. The function's a half, not 1.5, not log 1.5.
Oh, it's 0.5.
Yeah, it's log 1 over 2.
There you go. We have the same. But let's see. This is weird. You were right. How in the world is this 0.3 when like you said that the function moved? I just bought a calculator. I'm getting it on Friday.
Oh, yeah?
Yeah.
Did you Amazon it?
Yeah. Fully
What's your work schedule like tomorrow?
like for tutoring or what?
Both.
Well, tutoring I work just in the afternoon.
Are you working over at Freshens tomorrow?
Yeah, every day of the week in the morning.
What time do you get done over there?
At 2.
At 2? Okay.
Mm-hmm.
That's too bad. I was going to invite you guys. My Vivint, the company I work for, is opening up their new building, and they're giving away a bunch of stuff and free food, and they're giving away $500.
For what?
Like, they're doing like a basketball shootout.
Oh.
And anybody can do it.
That sounds awesome. What time is that at?
It's from 10 o'clock to 2 o'clock.
Perfect.
That's why I said that's too bad.
I can just not go to work and I can go to your thing and I got like 500 if I do that.
If you win.
If I win.
If you win.
How many throws do you have to do?
I don't know. I don't know any of those details.
Oh, okay. We just know that they're giving away 500.
Yeah, they announced it at the conference I was at this weekend.
Okay.
This last weekend, anyway.
Gotcha.
Vladdy, what are you doing, man?
I just got back. What are you guys on?
The last
We're
one.
done.
Are you done?
Kind of. I mean, we didn't.
Okay, but we did get this.
We know we know what the graph is, so.
Yeah, but I have no idea how we got that graph, to be honest. It was different.
Guys, let's be honest. This is why we have graphing calculators.
Yeah, that's true. Okay, let's go to the yeah, let's finish this one and then just go. We're done with this one. We already did the graph, even though I have no idea how to do it, but graphic calculator.
It's okay. That's what the tutor's for.
Mhm.
All right. Let me stop this one, and then I will send you guys invites
To the
to
new
the
one.
next one.
Okay, sounds good.
All right.